Oh, hey everybody. Today is December 17th, 2024, and you're in the Gimbalabs Playground. Thank you. Thank you for coming. We meet here most Tuesdays. You can check the calendar at Gimbalabs. I want to say hi to our wonderful host, Steve Lockhart. He is the showrunner and the producer of these playgrounds for this year. My name is Newman Lanier. I'm Steve's colleague, and I do these little rambles, and that means that I'm mindful of the agenda and the time. I monitor the chat, and if there's any feedback or issues, you can let me know. I'm here to help. So, kick things off, I want to say thanks to you for being here, you and you and you. I see a lot of folks here. And I want to say that the recordings are posted on YouTube and with that, if there's any other questions, you can ask me directly or in the chat. Um, and I think I'll pass it over to Steve. Steve,
Thank you,
how's it?
Newman.
You're welcome.
Newman's Newman's most valuable help in this is talking to me once or twice a week before we do these playgrounds because we just kind of go over stuff, and it's always very helpful for me.
Thank you,
Um,
man.
I'm I have no idea, but my headphones are not working, my little AirPods, but I guess you guys hear me okay, right? Okay.
Yeah, we got you.
Um,
Can you hear us? You got us?
yeah, no, I hear you all fine. So our first guest, we've got two guests today. We've got Sebastian Pereira and Ricardo Starksas, who are working on a proposal that they were funded on building an AI assistant for documentation um, for Cardano developers. And I'm not going to try to describe it technically, and that's kind of what I hope they'll do for me and everybody who's watching. I want to welcome everybody. Our second guests are going to be some of the team from Cardano After Dark, which is a game playing platform that is focused on poker that has been in process for how long? When did we start talking about it, Simon? It was a long time ago. It feels like I don't know if it actually was a long time ago, but you
I
guys have
think
been
probably like 3 years ago. What
maybe,
do you
yeah,
think, Patrick?
maybe,
Yeah, roughly 3 years.
yeah, yeah. So anyway, let's start out. Sebastian, Ricardus, if you could introduce yourselves and kind of describe the problem you're trying to solve and how you've approached it.
Sure.
Oh,
Well, my name is Sebastian. I've been in Cardano since 2020, right? Since Fund 3 on Catalyst, quite a bit ago. And the idea is that the Cardano documentation has always had a problem of fragmentation because Cardano has this unique design of having three funding entities. And those entities all work more or less like silos. Each one does their own thing, and there is a bunch of useful stuff that is spread between them. And if you're trying to develop on Cardano, then you have to be aware of all of the three entities and what they're doing any given time. And that is very complex, tedious, and quite a waste of time. So for that reason, Ricardo and I, we made this proposal on Fund 11 to create a tool that would combine open source LLM, a vectorial database, and a bunch of scrapers that would monitor certain important repos on Cardano, automatically update whatever new things were pushed there to the vectorial database, and the LLM would use that as a basis to answer questions, either generic questions like what's Ouroboros or how transactions work, to code-related questions in specific languages like Icon and Lucid. So we got funded, Fund 11, and we are delivering our milestones. And today we want to show the project and also how to install it in an environment and how to start using it. So if Ricardo can take it away.
Yeah, hey, I'm Ricardos. I will show you the part where we deploy it on the Kubernetes environment um, because now it's like a stage where we can show that. Before we had it deployed to Google Kubernetes Cloud, well, Google Cloud Kubernetes Engine, and now we created the way for companies to have it accessible in the office. For example, you don't want to, for example, use or rent Google or Amazon or any other infrastructure. So you have maybe some computers, servers, or something that you can use for cluster. Then you can create a Kubernetes cluster and apply this project. Yeah, it's compatible. Of course, I can go a little bit also about the Kubernetes cluster itself, setting it up, but you might even have already set up, and so we will go through the scripts how to deploy it. I hope it will be somewhat interesting. I'll share the screen.
You should be able to share the screen. Let me know. Okay, you got it.
Okay, yeah. So let's first see the what I did about the Kubernetes cluster. First, I thought maybe I should use some smaller version of Kubernetes like K3s or something, but then I found Talos Linux. It's perfect for setting up a Kubernetes cluster, so I started to use that, and I just ran. Well, I just created some scripts. For example, I can do. Yeah, this is a one script like solution for building the whole cluster. For example, you you write down some already prepared nodes. So uh, for those who not are so familiar with the Kubernetes cluster, this is a thing where you distribute your applications in the cluster, and they are highly available then. So you can, if something crashes, some other node will cover up, and uh, it's very nice to have like in a real business environment. So, and for that, I use Talos. I use Talos Linux. So you have to prepare some control plane nodes and also worker nodes. So you can see I prepared some control plane nodes. What these are actual like IP addresses, but I already made it like DNS records. Like I could ping this, so I can use control plane one dot soft. It's like my way of tagging the network devices to not trying to remember the IP addresses. So these can be just IP addresses of the computers already prepared to be in this project, or all in in Talos cluster. Worker nodes also and for example, your cluster will be accessible through one single link. So I also prepared that. And what you can see, it's like going through each of the control plane and applying patches. For example, let's go to patches. I won't talk too much about this, just going through quickly. For example, I prepared some patches. It has a different host names, but also there are common patches like where to install, what actual image to install, some other things. And also I did the RAM optimization because I have a lot of RAM and it can be used like as a disk to store database, and then it will be much faster. Yeah, so that, and maybe I just go to the deployments themselves. The project is consisting of can say 5 parts, but one of the parts I launched I had already launched somewhere else, so I did not do it in a Kubernetes cluster. So the parts that are mandatory is document scraper, front end, NFS server is like a file server in the network, accessible like a mountable folder. So this, I have this already in the other server. So I use that. Also Olama deployment and PrivateGPT deployment. So these are deployments that are used in this project. So first, maybe let's see how my cluster does. For example, I can do kube control get nodes. So I have 6 nodes now. Well, 3 are control planes and 3 are workers. One of which is GPU worker. So that's why currently I'm on the laptop, because actually what I did the bare metal install on my GPU computer, because bare metal will not have like virtualization overhead, so it will be even faster. So I did this bare metal, but others are containerized and virtualized. So, but yeah, okay. So maybe let's see uh, how can we deploy something. For example, let's deploy Olama service. Um, it's it's a service which runs actual AI models for this project. So you do everything like that: kube control, apply file, and then you see, for example, we do Olama, and I already have a file for that. It's called deployment. So we create the deployment, and I already made some watchers, and I can see this Olama deployment already did its job. So it's ready. So we can do
Can I-
also, yeah,
Can I ask you a question here?
of course.
I'm seeing how you're setting it up and everything. Is Olama your large language model?
Yeah.
And where'd that come from? Is that open source or did you guys make
Yeah,
that?
Olama is an open source project which is used for you to load AI models in your
Okay.
computer. Yeah.
Okay.
So before that, I did in some other ways, but then this project came about, and it's much easier to manage models and everything. So it's so much better. So I implemented this. Yeah.
Is it somehow oriented towards coding language more than others? I mean,
Well, it has API, so you can use it in any programming language. So it's and it also complies with OpenAI API standards. So if you have already something for using ChatGPT API, so you can also change that to Olama API. So yeah, so we already deployed the deployment itself, but now if we want to reach it through the web browser or other deployments, we have to do the same, but now we are deploying the service. So I will go through the files. I I might already have deployed the service, so it's left unchanged. So let's go through quickly from about the deployment. So not front end, it will be Olama deployment. So it's a thing that has like creates a pod, and in that pod there will be a container. This is open source path to it's a path to open source container Olama. We pull latest version, and we also say that we will need NVIDIA runtime for that. So Talos Linux wouldn't try to schedule this deployment on some incapable computer. So this is how that works. And we might even check where our actual deployment is now. Deployment is here, but if we check pods, we see the pod. And for example, we could check all the pods that is currently running in our namespace. So kube control, get pods and namespace Cardano Smart. So we have one pod and it's already running. But if we do option wide, we can see where it is, and it's in the fractal because, as I said before, it's the only GPU server currently. So it got deployed in that server. Okay, so, and let's do a little bit of review for the service, Olama. The service is a very simple thing. How to expose it to a network. So I won't bother you a lot about that, but also we should apply the model downloader. I've written this model downloader that can reach the Olama service and then download and just then exit. So let's do that. Kube control, apply. Yeah, would be file, Olama, Olama model downloader. So yeah, it's it yeah, so it let's see. Yeah, we have this, we have bash, Olama model download. Yes, so now maybe it might be a cron. Yeah, okay, let's do it that way. Let's delete now this. Let's do, yeah, let's delete the job because this job, I think it's already done the job before this show. So let's do kube control delete job, and then we can do model. Oh, first of all, namespace Cardano. Then model. Yeah, online model downloader. So delete it and then just reapply model download. Yeah, so now it got created and now it's running and it's downloading the models, and it will be automatically exiting when the models will finish downloading. Okay, let's go to second deployment. It will be doc scraper. So this doc scraper will automatically go through a list of documentation links and then scrape it to the common server. So let's go kube control, apply. This time it will be doc scraper, and it will create a cron job. What is cron job is, well, maybe what is cron job. It's like a thing that repeats itself and does something at certain time. And time can be like set in advanced way. But yeah, so it is currently, for example, as I tested, I set maybe not that good time for it to do a scraping, but actually on the production, I would say the best time would be like 5 a.m. or something. It gets scraped, and then in the morning you have the newest documentation. So this does automatically. Yeah, so, but we can also maybe schedule it that we can do it like now. What is the UTC time? Current UTC. You will
18.
see 18. Oh, so okay, so
1825.
okay, 18, 25. Okay, so it will be make 20 like 27, and then we can apply this cron. Okay, so I applied it, and we have it in crons. Yeah, so this will automatically now launch and scrape the documentation, and we can just leave it like there. let's go to the second thing, PrivateGPT. PrivateGPT is a project which helps with many things. Like one of these can be loading the model using Olama service. Then it can scrape the document. Well, not scrape. Scraping is the other. No, that one. But it ingests the scraped documentation and converts it to a it's what it's called. I forgot the word. Yeah, but it's data which can be put into a vectorial database, and then you can embeddings. It's called embeddings, and then you can, when you do a search, semantic search, you do a search prompt. It also gets converted to an embedding, and then compared to this database data, and then gets back to with a some chunk of data which is very relative to that what you typed, what you asked, and then all this sandwich you load into the model, and then model answers the question for you and gives you back to the user. So all these things can be done with that. So this is the biggest node. So let's just keep control, apply F PrivateGPT. It consists of many things, like consists, let's say, okay, so PrivateGPT, where are you? Okay, so cron job for starting, because well, I will improve that in future, but for now it has to restart when it ingests, because there's only one user in the database at once, because it's now socket based, not service based. But this is a problem for future, not that big of a problem. So and also the deployment. As I said, it works in RAM, so I made a RAM storage for it, for the actual database. Volumes, also some these things are just for making it accessible to restart. So let's do it all. So first of all, cron job, for example. Let's check the cron job, and maybe let's check the pod. Yeah, so our scraper pod is already running, as you can see. So it's scraping currently. We can even check logs if you want, for example. Just copy this name, cube control logs follow, and then just paste that. But we have also to show which namespace. Yeah, so currently downloading the from site the links and saving it to the database. So just can go out from here now. Let's continue by installing the actual PrivateGPT thing. So PrivateGPT, yeah, so 5 in the morning, it will relaunch to re-ingest the data. So that, yeah, but this is on restart. So this is just for restart. Just so it's not, it's okay. Also, let's do the deployment. Yeah, so deployment will now try to just no. Let's not launch the deployment yet while we don't have ingested the first batch. So maybe let's just wait a bit with this. We could do, for example, we could do volumes. Okay, PrivateGPT PV, yes, PV dot YAML. So this is a volume. Also PVC, it's a volume claim. Also role binding is for restarts, for rights to be able to restart. Service account, and of course service itself. Yeah, so we did everything for the ChatGPT. No, not ChatGPT, sorry, PrivateGPT. Okay, so let's go to second. Well, not second. Next, it will be the front end. So we can launch the front end, no problem. So keep control, apply. So, apply. So apply, file, front end, deployment. Okay, so the front end consists of two things, deployment and service. Oh, sorry. Service. So yeah, two things. Yeah, so we already have this. Let's see what's happening here. Still, well, I measured the time. It might take like, I don't know, 7 minutes or up to 10. So we'll see. But let's check whether we have everything. Currently, we have these pods. So downloader already finished its job. Olama is ready to take prompts. Front end is already running, and yeah, so it will be accessible. We'll just see. And doc scraper is still scraping. So after scraper, there will be also ingester. And so we will have to wait a little bit, maybe to save time. Maybe at that point we can just go with next next project. I don't know, but just before that, maybe let's check
Well, let me,
yeah.
can I, when, after it's gone through the process, is it, what is it putting out? Is it putting out a markdown file, or are you going to have to, like as the repo host or a manager, are you going to have to, format whatever is outputted?
Doc scraper is kind of complicated thing, but it already makes sure you have clean data without any images incrustated in this documentation, without anything, just because language model, well, at least for now, it's best only for giving it text to ingest. And if you want to ingest images, uh, it also can be done, but not in this project. But so that's why I still well, clean them. So this is another okay, so I can show another um project where is actual project. So you can see the actual scraper. Okay, so I already selected that, I think. Oh, it sees, okay, it sees the project in another window. So yeah. So also quickly, yes, this is a data already scraped when I tested it. Yeah, but the documentation scraper consists of several spiders. For example, Aiken spider, Doc spider. This is for Cardano docs, Haskell, Lucid, Mesh, and Plutus. So for example, let's get, for example, Plutus spider. Everything is just for this, well, website. Of course, now we can have AI-based scrapers, which can be much smarter. And but I did the old-fashioned way. But this is much faster and much cheaper than using the AI scrapers for now. So, but these scrapers make sure you have, I can show you the data. For example, I don't know, Plutus. So these files are in Markdown. Um, for example, you can see ledgers. So everything is in Markdown, and the links are also available, but this is the best way to give it to the model. So yeah.
That's cool. So
And
have
yeah.
you guys, have y'all been able to get like cooperation from any of the big three, as you build this? Are they, I mean, do they have plans to implement this?
No, we done a few live demos with Hamburgo, right? They help us out with getting it out there. But in terms of adoption, no, not really.
So, but the idea, like when are you showing basically a complete thing here, or there's still there was something early on that you said you were still working on? Is this going to be complete and just out there for people to implement as they want to?
Yeah, yeah. So the idea is
Oh,
to have
you,
it open source. Yeah, sorry.
oh, there's a front end to it. I mean, you don't have to, I mean, well, I guess this is your local front end, or would it be a
Eh,
service that we can just jump in and use?
Yeah. Well, at one point, it already was deployed on Google Cloud and was accessible to many more users. But this was a test phase because, well, we just made it possible for testers to test. But if you want to actually have it on your end, like pay electricity and everything on your side, but have it available, you can deploy it. For example, now at the office and I deployed it in the office infrastructure. Um, yeah, and I can
Hmm.
access it. But of course, I even can share this to World Wide Web, but I only have one GPU currently, so it will be um a little bit, yeah, slow.
Yeah, yeah.
Yeah, but
What
in
I think Patrick had a question. Go ahead, Patrick.
Yeah, I do. First of all, it's a very interesting recommendation system applied to our documentation. So if I understand correctly, you have Ollama that does ingestions, runs with a cron every day,
yeah.
transforms the HTML into a format that is parsable from the AI, stores information in a database, and then you have an application front end that basically takes your question, vectorizes it, try to recommend you the document that is most similar to your question. That's why if
Yes.
I search for icon, you'll bring me to the best pages. That's
Yes.
lovely.
Yes.
Uh,
And yeah.
you said that I saw you use a Llama 3.2. How many parameters are you using? Which
3
your
billion.
model? 3 billion. Okay, so it's fast.
Yeah, but I tested also 7 billion, 8 billion, 13 billion, several models.
Yeah.
So I was happy with how Wizard LM worked, second version. Also, Llama 3.2 works nice. Llama 3.1 also works nice. I also tested the 3.3, but with this GPU, even if it's 4090, it has too little RAM to actually host it. So I wasn't able to use it for this project currently.
So just to give a sense of scale, how much RAM are you talking about? What would you have needed to run that?
VRAM, if we are talking about VRAM, so 4090 also only have 24 gigs and it's too few. So we need at least well, probably it will be like 25 gigs, but I don't have it. I have 24, so uh, often it's often the case.
That's what she said, right?
Okay. Yeah, so but you don't need a fast GPU. You need well, maybe you can buy some older GPUs and they have like 24 gigs of RAM and you can get like several of these, two or four, and then you can load big models and it will
We're
be
talking about 1 or 2 thousand per GPU, even old dollars.
yeah, yeah. I recently found on eBay, I found P40s, which were well sold by some seller it was 500 or so on one GPU, so a little bit less than 500. So buy two of them, you will have 48 gigs of VRAM, and you can then use it, the best models. Well, at least the 3.3, you will launch it.
Let me get to my the end of my question. How can you parallelize these? Because you need a lot of GPU, sorry, and then you need to present a front end that needs to serve possibly a lot of people in a company or in our ecosystem.
Yeah, so you can launch however nodes you want or you need. For example, currently you can see it's a Proxmox virtualization environment where I prepared some nodes, for example, three control plane nodes and two worker nodes. And one is not in here because I installed on bare metal. But I use this, and you can scale. Well, at least if you still have some space, scale here. You can see, well, not everything I have launched here now, but I still have space here, so I can still scale. And this is when we are talking about hardware, but in the software wise, here in the configs, you can, for example, you can scale. You can see front end replicas only one, but you can scale like three or what, however you want. Also, Olama, which is very important. Currently, I only did one, but when I did it on Google Cloud, it was three replicas ready. So this is only like changing a number and redeploying, and it yeah it just schedules the new nodes, and it will be ready to be, well, have more users, and it works. We tested with with several users. I worked with like three browsers at the same time. Other users tested also. And it's not like if you have three GPUs, you only have three users at a time. It's not like that. It uh, it's you just making it available for more users. Yeah.
We kind of have to give the Cardano After Dark
Okay.
After Dark team their time. How are y'all set? Are you on your last milestone as far as the Catalyst proposal? Where are you at, and how do you want to wrap this up?
I think, yeah, unless I missed some detail, and Sebastian can correct me.
Yeah, I mean, we are in the penultimate milestone, right? The one where you have to have some deliverables. The last milestone is just the formality of the report and the video.
Mhm.
So yeah, we have to do some stuff for this milestone. And one of them was tutorials of how to install it. And then after that, we'll just publish the GitHub with instructions of how to basically put all our running. And then that would be how we close. Maybe in the next catalyst, we would look to expand the project at other things. But yeah, that's a question for that whenever that happens. Well, I don't know how much time we have left, but I don't know if we can do some questions to the bot to see how it works, and people can get a sense of how it's answering, and then we can close it.
Yeah. I just saw that the scraping was done, and now we will have ingesting. Yeah. So, and after that we can do it. So maybe let's go, if you can, let's go to another project, and maybe the ingestion will be done by then. Well, at least I think it will be done. Yes.
Okay.
Good.
All right.
Sounds like a good deal.
Does anybody got any questions they want to ask before we segue?
And we can also ask at the end, if you, yeah, because then the machine will be up and running. We can ask the service some documentation questions. That'd be fun.
Yeah.
Cool. All right. Simon, Patrick, you guys want to kick it off?
I would like to share, yes.
Sure.
There you go. Oh, are you there? Can you do it?
Yeah. I'm sharing.
Let's see. Yeah, give it a try. It should work.
Open system settings. Oh no, really.
Oh boy.
I need to restart, probably. Yeah, I'll join you in a second.
Okay. But this is hey, if you're listening to the recording, this is a Gimbalabs Playground. Why don't you come and join us one time and see how you like it? You can also get on to our Discord. We have all kinds of wonderful things laid out there for you. And you're probably watching this on YouTube. Why not leave a comment or subscribe or like or do all that stuff if you feel it. Hey, thanks for being here. And Cardano After Dark will be coming up next. I've got a couple of links. I'm going to drop them in the chat so you can peruse.
Thanks,
Yes.
everyone. Oh, Patrick, that was quick.
Yeah. So I'll try to share now.
Ta-da!
All right.
Okay. Can you see my sharing?
It worked.
Okay,
Yes.
that's great. So guys, I present a little bit of our application and name of the Cardano After Dark team. You can see the faces there, and many of the project members are in this call. So what we did is we implemented a system with an infrastructure that enables us to exchange messages and an application that can use this infrastructure. We were missing a side channel like Hydra, and therefore we created our own solution. We did not really get funded for this, just a little bit, but in the last couple of years we did not get any funding. But long story short, I show you a demo of the application that is running on top of the infrastructure, and then later I'll explain a little bit of the infrastructure. The application is a dApp that is called Cardano After Dark. Our first application is called CPoker. Let's say you are two, Alice and Bob, and you want to play poker the old way, like at my place, and you don't want to use a centralized server. So Alice joins the table, Bob joins the other table, and you start a game. But basically, when you press start, something complex starts running on the server. And you exchange some cryptographic information, which I won't explain now, but later I will. And you have cards. You can see your own cards. You cannot see the other cards, but you have cryptographic security that everything is fine. And then say this player starts. You see, in this case, is Bob starts betting 20. Alice calls, and then you
While
see
Patrick plays through this game, I'll just give you a preview that once the demos are done, we're going to actually have also a segment on tokenomics for the DRED protocol.
Absolutely correct. So it's not just the game and a little bit the idea of the infrastructure, but we show you also the tokenomics, why this should work. So this is still the game. It's going to be a very simple demo. You basically proceed betting or calling in the game. You have some information that are public to everybody, some information that are private, and then sorry, I think I had a problem. So that's the demo effect. Let me restart the application, please.
Oh, man, no. Dang
It's totally normal.
it.
Still under construction.
Yeah,
You
if
know,
you say
and
so.
the interesting thing about this is not a toy. It's based on, I was looking through some of the documentation, and it's based on like one of the foundational research papers of Cardano. This was one of the use cases that they set out way back when. So I'm really stoked that we get something that's looks really cool.
Yeah,
Yeah,
this was
I'm not sure if it's one of the foundational documents, but it is definitely one
early.
from IOG, the Kaleidoscope paper, Royale, and 21. So it's 3 papers actually.
Yeah, let's say that we worked a lot on the channel and on the cryptography. And now I shall be able to show you the working game. Okay, now you see that there is public information that both the players can see, but also some private information. That's the interesting part about the game of poker. It's a mind game where you have some public information, some not public information. And then basically you keep playing, back, and all this information is exchanged in the channel. Almost everything is encrypted. Everything is encrypted except the data you send to the actual channel, which is part of the work we are going to do. All the players can reconstruct locally the whole history, and they use El Gamal group encryption and decryption in order to have the information visible, some information visible only to himself, but give the other the cryptographic certainty that the information is right or the cards are properly shuffled. I will stop here with the technical and cryptographic questions, but if you have questions, please ask them. What actually happened under the hood is that when you start a game, in this case, we just hope that we don't see the same issue again. When you start a game, you are joining a neighborhood. Let's think it's like a channel. Okay, and when you start this channel, you start exchanging with when you press start the game. You start exchanging cryptographic information, and you agree on a shared key that you then use to encrypt the data. And then the game is, a sequence of operations that have to be fast. That's why we use the Redis, because it's the best-in-class solution to have fast application over the internet. And at the end of the game, all the information, what you played, is then persisted on chain. So this is the actual speed that you'll be able to play the application. And at the end of the game, every transaction that is signed is going to be persistent on the blockchain. I think that's about it. If I don't want to go too specific.
I could say a couple other words about the DRED communication channel here. The demo was only for 2 players, but the communication channel supports a multiplayer communication path so that any number of poker players up to the practical limit, I think, of 9 in a game can participate in the same cryptographic protocol. And every single participant in that cryptographic protocol, the way that protocol is constructed, each participant's algorithm gives them their own guarantees of shuffle fairness and card privacy. It's a pretty cool feature of that Kaleidoscope protocol.
Can I ask?
messages traded through that communication channel are just simply broadcast to each of the participants.
Can I ask what you built this on based on the paper that Input Output wrote, and what I'm wondering about, because I've been playing poker with the Cardano Stoners Club on Saturday nights, and we started having a discussion about a month ago because I personally had seen enough hands to see how it started to feel biased to me. And so like there's a tech guy in that Stoners Club in that Discord server. And so like he did some research and came back to us and said like, yes, this algorithm, which the name of that algorithm was the Mersenne Twister algorithm with a sequence of random seeds. And I'm really curious, what is the algorithm that's determining the shuffle, and how it's dealt out to the players? Is there a name for that, or can you describe that somehow? Because I've become very curious about it after practical experience.
I can answer that.
Yeah, go ahead, please, Jake.
So the way that we have it right now, it's using a Fisher-Yates algorithm for the shuffling. So how it works right now, there's a dealer that's specified. That dealer, in this case, has the unshuffled deck, and that person shuffles the deck using the Fisher-Yates and then encrypts the product of that. And then that person passes it to the next player, and the next player does the same thing, shuffles again, and then re-encrypts it. And that goes all the way around. So if we have a 9-player game, each one of the 9 players is doing a shuffle sequence, and they're also re-encrypting it. So there couldn't ever be really a bias in that, especially because every person is going to be doing the shuffling that's at the table.
Yeah, that happens in this. We're playing on poker now, and that sequence happens. Like it goes around the table, based on the last winner. But what we started to notice, and my thought is evolving on this. What we started to notice 2 or 3 months ago was one guy would seem to get the best hand. One specific player, in a group of like 6 to 9 people. And yet, what I've noticed in the last couple of weeks, because I've really been focusing on it, is you can still beat it, but that's more about that personal dynamic, and that mind game that goes on. And it's been very unusual.
I have a lot of poker experience, and I would really like to speak to that, because this is something I hear from a lot of people who are playing online, especially from people who have been playing offline and then went to offline. And I was playing professionally for a while, and usually, so when I investigated stuff like that, of course, there's the possibility of something like that happening, but usually it's a bias from the player. Like you wouldn't recognize if there was a bias from the algorithm, most likely, because you have to play so many hands to see through the variance. You need to, in order to know if you're a winning player, you have to play like at the bare minimum to get like an idea of if you're a winning player. You have to play 100,000 hands.
Mm-hmm. Yeah, that's what it feels like.
Yeah, what you really want to look at is like a million hand history before you know if you're a winning player, and that is a large sample that you probably haven't played on Poker Now yet, right? So,
but we started, because
personal bias in this instance, but I don't know. Maybe Poker Now uses an algorithm that is biased. So
it's
I don't want to
interesting.
defend them, right?
It's interesting to go on Reddit, because there's Reddit about Reddit subreddits about everything, and people give Poker Now a lot of shit, but it's very, very popular. And for us, like what we notice is like, you're going to have a great hand, and then somebody will pop up with a four of a kind, and you get these combinations of two players or even three players having really great hands, and it's very exciting. And even though this Mersenne twister algorithm, it gets criticism because of that tendency to go in a game, it has a tendency to go towards a specific player over the course of a game. You still have these possibilities for, unbelievable odd, hands with unbelievable odds, happening. And so like it's a very popular website because I don't know, it's still unpredictable, even though it feels biased. But what I have noticed is if you come in and you play conservatively, you can win. Like if you really know how and when to be conservative. And then the mind thing of just, convincing people you're not bluffing.
Well, you bring up a good point, and from my understanding, Poker Now it's all centralized. So the Poker Now servers are what is doing the shuffling algorithm. So there's no way to prove whether or not it's actually being biased unless you're running a really big simulation. But in this case, each one of the players themselves is doing the shuffling, and then there's a zero knowledge proof that can be provided to ensure that it's actually shuffled.
That's cool. That's interesting. I have talked to the guys about what y'all are building, and so we're just kind of waiting, because I do think that we're going to give it a try, in these weekly games. Whenever you're ready.
Well, we did not get funded for the CPoker development, but for side activities. So we need to keep on going with the CPoker development with other stuffs. But at least we get funded to try to use the Hydra channel and improve the DRED channel to send information. The application itself was not really funded. We did it, for ourselves. We are building a company.
Okay. Could you explain the DRED thing for me real quick? Because I'm not sure what that's referring to in the whole package.
Yeah, of course. So, transaction
If you
on
could
chain.
also show the slide deck.
Yep. You
Thanks.
you want to question, Randall, do you want to take over? You want me to go on?
So just real
Go
quick,
ahead.
DRED is a messaging layer solution that we use for CPoker so that the messages can be sent like really, really quickly because DRED uses in-memory databases. So you're not going from your hard drive, you're going from your RAM, which is much, much quicker and also like a bottleneck from when it comes to serving data.
So if you think about the moment you started using Twitter,
real quickly,
and
you need that because in a peer-to-peer network, you have a star-like connection to every player, right? So you need to serve all the players in the star-like network, and this needs to be really quick. Sorry, Patrick, go ahead.
Oh, sorry for interrupting you, John. So basically, we use Redis, and Redis is a super fast cache that enabled us to have Web 2.0. So this web that was highly reactive, responsive, not only request response. And we thought our initial idea was, okay, Hydra is not fast enough. Well, 3 years ago, Hydra was not. Stop, period. But we developed a solution that will help us carry the application on, work with the our protocol, and also see if it's possible to, also use Hydra together. But that's, our current development, can't talk a lot. But DRED is the infrastructure that enable us to quickly interact. And this is our game changer because we are going to propose this as a platform. You want to have blockchain applications, yes, but you don't want to wait 15 minutes, correct? You need to have your cryptographic protocol, and at the end of your cryptographic interaction, you will persist the results on chain. And then we decided, okay, which application can we use as a first example? By the way, keep in mind that we need to also to make money because otherwise we cannot deliver. And we decided that poker was a perfect idea. We had the competencies, the will, the passion. That's why we have what we now call DRED, and it's our communication infrastructure. And then what we call CPoker, which is our best application in our mind to develop on this. But we want more applications like CPoker. And Randall will explain you how we are going to shape our tokenomics to get to that point.
And
Well,
I think Simon has a few things to say first, but Steve, I also want to add something to the answer about what DRED is. As a network, the DRED server, the one copy of the DRED server can reflect messages to multiple players, but the DRED network is going to consist of multiple DRED servers, and this lets players connect to multiple servers, and because those servers will also share the communication channels, it adds decentralization so that even if any one of those servers is not online, all of the messages in the channel can continue to flow. And it would be completely transparent that the fact that one of those machines went down
So
right in the
you,
middle of your poker game.
right. So you're really looking at wanting to build out a network of node operators to do this then,
Mhm.
or is there some way to do that virtually? You do want node operators. Okay.
Sure.
Okay. That's interesting.
And Simon, that's your cue.
yeah, Patrick, can you go one slide before that, please?
Sorry? Yeah.
Just so I can, finally properly introduce ourselves. We're Cardano After Dark, Patrick, Jake, Randall, and me. So we had some past success with developing DRED. We got funded for that. We delivered on that. The same is with, back then it was called Cardano After Dark Hold'em Poker. We renamed it into CPoker. We got funded for that. Was a bit more complicated. To be honest, it was my mistake. I was trying to deliver the full application with 40,000, which obviously was like dreaming, but we still got a prototype, which is roughly what you would need 40K for.
But I mean, when you did that, there wasn't the funding amounts that we have now. So I mean, I don't necessarily feel like it was your mistake. It was just part of the constraints of the catalyst.
Yeah, I mean, I'm trying to own up here because we did, or I was promising to deliver a full application and we couldn't. And I hope people forgive us for, over-promising, but at least we delivered, something that is worth the value that we got. Yeah. So, but anyway, we're also part of the community. I'm sure many here know us. Maybe Jake, who's our newest addition, is not as well known, but he's definitely like an amazing contributor to a team. I can't go.
Like superhero style. It came to us in a moment where we really needed help to get the cryptography right, and it was amazing. Like you take any of these 4 people out of the team, we wouldn't be able to succeed.
Yeah, Jake is our science guy. All right. So can you go to the next slide, please, Patrick? Thank you. So yeah, we've been talking already about DRED, our communication infrastructure for dApps, and I hope in the future there's going to be many dApps being built on DRED. I think it's a good solution for decentralized applications. And then CPoker, our poker solution. Next slide, please. Okay,
Sorry?
so Yeah, so we are planning on creating our own utility token, which is the Redis token right now. It lets us do three things. It lets the end user pay for the infrastructure. It rewards the node operators, and it enables dApps to monetize on their on what they're building. Next slide, please. For this tokenization plan, we had to look at regulatory and tokenomic concerns, and those 5 here, these are really what we were looking at in terms of not getting arrested for selling a token, right? So a clear utility, we have to have clear utility for the token. The token is a token necessary for accessing platform services. Decentralized governance, like if governance is centralized, that is a problem with the SEC. Have a product before selling tokens, a working product before selling tokens, and yeah, and other regulatory issues. Well, I guess it's 4 and a special one here. So, and now I want to give it up to Randall, please.
Thanks, Simon. Yeah, when we think about tokenizing, it'd be great if half of us weren't in the United States, and if we just wanted to go out and take a big risk and sell a token that didn't have stable economics, but we actually want to create the best form of stability for a tokenomics ecosystem. And so some of the design goals we're looking at include how people are incentivized, how people can use the token, and really the economics of having a stable ecosystem. And so by having people able to use that project token to pay fees for accessing the network, this, by the way, also helps us not be relying on the poker application for like transaction fees and causing some regulatory problems on the gaming side. But we're really structuring the network to be all about communications. And so economically, by distributing those fees that they collect to the node operators, we really want to support a viable operations plan that each node operator can participate in and have their interests align with the interests of our token ecosystem. Other factors in a healthy ecosystem include having the circulating supply match with the amount of operational volume, and that needs to probably change over time. If you have 100 players or 20,000 players or 100 application users or 200,000 application users, those are massively different amounts of volume. And so we want to meet that with an evolving supply of circulating tokens. And the last point is about having enough capability to evolve our operational parameters so we can respond to future conditions. Parameterizing, of course, Cardano did it, but it's not something that we've seen a whole lot of from Cardano token projects. Next. As we move into the phase of opening the token sale, which is not today, but as we do, we have a plan for applying the proceeds of those tokens. And it's about paying for ongoing development and acquiring new applications to grow the network's revenue streams, covering those costs that will help us grow. And that's the purpose of those funds. And on the token side, we are holding a significant supply of those tokens in our allocation plan in order to incentivize growth, involve community in contributing to the success of the project, and really spawn the supply, particularly on the app development side, the supply of available applications that can run using this decentralized communication protocol. And again, with gradually releasing the token supply, we want to support organic growth and avoid kind of the disruptive chaos of value of the token that we sometimes see with these token projects. And overall, we want to continue monitoring for growth and health indicators because that can help us see when protocol parameters really need to change in order to flex with things that we know will happen in the future. And we can't know exactly what will happen right now.
Yeah, I think there's this fine line with building a community that's willing to buy your token close enough to the time that you're willing to that you're able to launch, because you can very, as we see on Twitter, you can so easily become castigated and labeled as, leeching off of the community. And it's a really tricky thing, like I don't know how I would go about what you want to do, because you have to develop relationships with fairly technical people who can run your nodes without making them feel like they're being strung along. So it's a very, very delicate thing. I'm paying attention to some of these ecosystems in Cardano just as an investor. And it's very interesting to me, the difference in tactics that they take, as far as how they do that part, Yam4 is a team that I've been amazed at how strong their community is, when their initial token offering was 3 years ago. And then, the team didn't really communicate anything at all. But now they're coming out and, everybody's excited. But that was 3 years, that token's been being held by people waiting on the different applications to be released, which is happening over the next couple of months. But I don't, it's a mystery to me how you do that, keep a community engaged that long, without having anything to play with, so to speak.
Yeah, and we've been focused on creating the essential technology that will help us bring value to market more closely in time to the actual token sale. And there will be some value delivered prior to the token sale and ongoing value developed post-token sale. And there's also a funding mechanism that we found through conversations with a lawyer who is has closely worked with IOG, as I understand it. And so by offering an NFT project ahead of the token sale, we can allow people to have the right to acquire tokens without necessarily having to have delivered all of the points of functionality that will be important for the SEC to look at and be regulatory compliant. And that promise of giving them access to a token allocation for their early loyalty to the project may just be the thing that unlocks the ability for us to fund the development push that it really is going to take to deliver on all of these tokenomics functionalities. And I think we have a couple more slides.
Well, just one suggestion on that, because your base product is poker. I mean, if you can make the game just work without all of this ecosystem development, but if the game will just work, I mean, people love to play poker, and I think that that's your easiest way to build the community you need to actually build out the infrastructure that you've got in your plan.
As a business model, our base product is not poker. Our product plan is all around communication infrastructure. If you go and read up a bit on the regulations around poker, like taking transaction fees from poker games would make us a gambling company and would come with all kinds of very, very heavy overhead, far exceeding the costs of working on a communication protocol business.
So we won't take money from the game of chance, which puts us out of the regulatory concern. And the channel is our business. Poker is one of the application that you can build on top of it.
Yeah, I'm not suggesting that you have to make money from gambling, right? Like Poker Now runs just on people who subscribe to the website. There's no money happening in the poker games themselves.
And we do have a few more slides, Patrick.
Yep. This is already the next slide.
You might be having connection. We're describing a couple of different forms of tokenizing communications for real-time collaborative apps. The two-token system
He went away.
It's me. I went away.
Randall, but
Okay.
Fortunate timing.
Yeah.
Yeah, so I'm not sure if I want to jump in like that.
he's coming back. He's coming back. I think he's on there. Randall, are you there?
Yeah, I'm back.
Okay, great.
I'm not sure where I cut off, but the point about this two-token system is that an application running on the DRED network, we plan to support them in their own tokenomics, and they can incentivize their operations, their operators, so that they don't have to be running centralized communication infrastructure. And then the one-token system, in the next slide, is more representative of how we're going to be running short term, where the DRED token will be the way that poker players can pay for access to the communication infrastructure. And there's, as you can see, we've planned out a distribution allocation for the token. And we probably don't need to spend much time on that. I think we have a graph on the next slide and a couple of graphs, visualization, how we see the ecosystem developing over time. And this harks back to the complicated slide a couple screens ago. And then I think we have a little bit more about on the next slides. About growth track. Yeah, this is really the interesting part for me, because having one application isn't nearly as powerful as having multiple applications, and enabling applications to monetize their subscriptions using Cardano to exchange that value, and using Cardano to share transaction fees with node operators. I'm hoping, Steve, that you're seeing a different vision of what our business model is based on this picture. It turns out that CPoker is just a use case, and it's a use case for people collaborating in real time, multiple users working together using this decentralized communication infrastructure.
Great. Indeed, one of the initial ideas was, say, even be able to implement e-governance through an infrastructure like this. But we needed an initial application that many people can use that can generate a little bit of network effect. And the poker application is nice because, there are a lot of poker players spending like 30% of their revenues that will go in online casinos. That will save a lot of money. We generate a network effect.
And we're visualizing a future where Cardano as a blockchain platform is used for regular world people doing regular world things. People pay subscription fees for applications, and they aren't doing that on Cardano right now, but there's no reason they can't. So that's one of our purposes.
Patrick, I would like to see Bridge online. I've always loved that game, but I've never been able to play it frequently. So you want to?
That's our next idea.
Cool.
Yes, that idea has been thrown around once or twice.
Well, and then I think of like, what's the, minimum? I'm sort of small and, even, or some type of starter or learner project that, could get people involved and engaged in building on the with DRED and with tokenomics, because to be honest, it's a little daunting. It's an interesting wrinkle, the tokenomics part of it. But I think a game would be really a great way to get over that uh, weird feeling and to start engaging with tokenomics. And I think games are a real gateway to seeing it done correctly.
Yeah, exactly. That's also one of the reasons why we went with poker. That was the initial idea, having a game being used for, it's often used for scientific purposes. Implementing a game first, because there's not much risk. Not sure how true that is with poker, but poker definitely uses less money than financial systems, right? So
Yeah, I guess, yeah. Because poker could be scary, but finance is even scarier.
exactly.
Arguably, a game like poker actually gives us better opportunities for advancing the science than pure financial systems would.
I agree. Yeah, definitely. But I've got Emmanuel thinking of games that he and his group of students could build. Yeah, I didn't know what to expect from the conversation, but I like the fact that now how ready for work is DRED?
It's a very good point, I would say.
DRED is working fine for our poker protocol. There's some future development in the way of generic encryption, so that any group of participants, say they're sharing a document and they have a trust circle, Ideally, that trust circle has an encryption protocol that's generic. And whether you're doing a shared document editing or whether you're playing your private game of friendly poker, or whether you're doing some other collaborative application entirely, that generic encryption protocol within the group will give them assurances of privacy. So that's one of the future developments. And as we grow also the network, we expect there will be an ongoing process of operationalizing and monitoring and ensuring that each node operator can scale their node to multiple machines. And so these are all part of our expected roadmap for ongoing development of the fundamental technology that works fine for the use case of poker today.
Love it. Love it.
That's cool.
I am monitoring the chat, or I'm monitoring the time. Looks like we've come towards the end of our 90 minutes.
Newman, real quick,
Yeah.
I just want to say thanks, Simon, Randall, Jake, Patrick, and I just want to say, Ricardus, you were letting some stuff run there. Have you got something you want to show real quick before we sign off?
Yeah, it already completed long time ago, so I can show you. Okay, so this screen, can you see the screen, right?
Yeah.
Yes.
I will take this down. Okay, so actually, yeah, you can ask question, and it will answer and show references. So maybe anyone has some ideas what to ask.
Oh gosh.
I don't even know the question.
Well, I can show you what sources it did scrape. So it was Cardano documentation, the main from the website, also Aiken, Haskell, Lucid, Mesh, and Plutus for now. Those sources, yeah. And the imported files there's a list of just imported files. So even some books. I uploaded books about Haskell, and yeah. So
Wow. How big of a database is that? Or I mean, that looks like a lot of documents.
yeah, when you measure the documents itself, it doesn't add up to much data, maybe 300 megs or something. But yeah, but when you measure the vectorial database, it's bigger because it has these vectors on any token, every token. So yeah,
So
it's
John,
yeah.
Jonathan's just got a question in the chat. What is the K parameter and what should it be set to?
I think he's joking.
Oh, he is? I think it's a good question for
I think he's
I mean, you know,
joking.
No, isn't it a good trial run?
Yeah.
What does it have to be set to?
Oh,
Right?
Yeah, sure.
Yeah.
Okay, let's just ask this.
I think we had a huge debate. I think it was one of those things that we
Yeah, so the K parameter is actually referred as a stake pool target. And opt not just K according to the provider context. This value should be a technical setting that impacts the saturation threshold for stake pools. However, its specific value isn't mentioned in text. And I could show where it got the information from. So it got from two sources, Cardano Protocol Parameters Reference Guide. Yeah, so I can even go to that source and read it.
That's great. I think most of the people in the community who talk about K parameters should learn that last sentence in the answer. Right? That's a really great answer.
Yeah, and also it can do coding, but well, for coding, it is well, I tested a lot of examples, and it would be best if you have, for example, your project uploaded, or maybe some ideas how you do things, some documentation that you customly prepared, and then it's very good for your project if you want to use coding examples. But I can show you something. For example, let's create an example Bluetooth code for some I don't know, just maybe interesting dApp. I don't
Oh boy.
just absolutely generic. Okay, you if you
See what
want,
happens,
you
yeah.
can just see. Yeah,
I mean,
that's
what's
very
interesting to an LLM? Let's find
yeah.
out.
Okay, so what it did. Okay, so let it okay, so oh nice. I never never saw that kind of PL. I don't even know what's the language PL, but usually it says like Haskell or Plutus when I ask for Plutus. Yeah, but it's maybe it's like
But that
Plutus,
is,
like
I mean, even just
yeah.
the game, players buy tickets to participate in a treasure hunt. Player finds the hidden treasure, wins all the remaining, and
Yeah, when you ask such generic questions, it does well do the same job. So so maybe
right.
it's
That's
best. Yeah.
that's pretty cool, regardless. I
That's
really
great.
like that.
Yep. See,
Patrick.
maybe Patrick can give us the our to take us on out. I am mindful of the time. I don't
Yeah,
want to
I do
overplay.
have a quick question for you, Ricardo.
Okay.
So I saw your ingestion, you are doing it in Python. I have an idea. Maybe it can work when you do ingestion. Maybe you
Yeah.
can hash everything you get. And if the hash is not changed, you don't need to reprocess it again. Are you already doing that?
Mm.
Yes, about that. I had some problems with that, and it's not like fundamental problems, so it will be solved, but only because it was not straightforward to implement it like the same day. I just took a little bit to aside that idea, but yeah, this could be, and it's a great idea, of course. It's a great idea because it will let us add up the documentation in real time, live, and because now we have to restart and have to re-ingest everything from scratch, and that was the thing I could not do it like you said, because now it's like we connecting to the database using a socket file, but we have to do it multi-user and serve it as a accessible service like through network. So when this gets fixed, then your idea would be also implemented. Yeah.
Yeah,
Right.
good solution.
Yeah. Thank you.
I love it. Okay. Thank you all. Thanks. That was a really fantastic playground. Lots of topics and discussions. Come and see us next or no, not next Tuesday. Tuesday, January 7th.
7th.
7th, yeah. 1800 UTC. It's an important time. It's easy to remember. And I do want to ask on the way out, if there's things that you liked or didn't like, you can please reach out to me. You can see our feedback Discord channel. I'm really looking forward. Steve, any last words?
No, I just want to thank everybody for being here. I really enjoyed the presentations. Lots of stuff to think about from both teams, and I wish you all good luck. I really like what all of y'all are building. It's really cool stuff. So, thank you very much.
Bye, all. Thank you.
Take care.
Thank you.
Thank you. Bye.